Thank you very much. Tonight we're looking at Australian geological evidences for Noah's flood. When we turn to the book of Genesis in chapter 7, we read of an event called Noah's flood. And there we have details of what happened. And these details have scientific implications. We read, for instance, that the fountains of the great deep burst forth. We read that the windows of heaven were opened, and the implications of those two statements are that the earth's surface broke open and water, which was under the earth's surface, burst forth. There would have been volcanic eruptions and steam generated. The rain falling indicated that the text indicates that the earth was flooded. And indeed we read that all the high hills under the whole of the heaven were covered with water. And that's why God had told Noah to make provision in building the ark. Now we have to ask ourselves, when we read Genesis and see that it is a sober, historical, eyewitness account of what happened, there must be implications. There must be evidence that has been left on the surface of the earth that we can see today. And that's what we're going to look at this evening. We're going to look at evidence here in Australia that shows the results of Noah's flood. Now I'm very careful here because it's all too easy to say that this evidence proves Noah's flood. I'm not saying that because, you see, I wasn't there to see Noah's flood. We have an historical eyewitness account, but it doesn't give us all the geological details. But what we can do is when we look at the geological evidence, we can see that it is consistent with the description that we have there in Genesis. And so our purpose as we view the slides, the illustrations of geological features around Australia is for me to point out to you those features that show all the evidence of Noah's flood. Those features that show that there was water on the face of the earth, moving with great speed and devastation. And the evidence is there in the rocks all around Australia. So let's begin in Central Australia. That's a good place to start. We have a very important feature in Central Australia, Ayers Rock. And you'll notice that Ayers Rock is roughly 350 kilometres from Alice Springs. Many people think that Ayers Rock is just outside of Alice Springs. It's not. It's quite a distance, 225 miles or 350 kilometres in a direct line. And Ayers Rock stands out there in the desert, surrounded by the flat desert plains. It's truly an awesome sight. It measures roughly 9 kilometres round its base and rises some 350 metres. That's over 1,100 feet from the flat surrounding desert plains. Now, of course, the Aborigines in Central Australia have known of Ayers Rock for many years, but it's only been over a century since European explorers discovered Ayers Rock. Now we need to understand something about Ayers Rock before we can discuss the geological evidence, and that is this. Many people think that Ayers Rock is like a big boulder that sits out there in the desert, in the middle of the sand. You know how you go down to the beach and you find pebbles washed up on the seashore, and you can pick up the pebble and there's sand underneath it. But Ayers Rock is not like that. As you can see in the diagram here, this is a diagram as if we'd taken a knife and cut through the Earth's surface. Ayers Rock, what we call Ayers Rock, is really the tip of an iceberg, so to speak. It's a very large outcrop, and there's more of the same rock underneath, and it's shown very clearly on that diagram. Indeed, there's more of the same rock under the desert sands surrounding Ayers Rock. Now, you will see on this diagram that I have drawn those lines almost vertically. I've done that for a reason. Ayers Rock is made up of a particular type of sandstone, what geologists call a sandstone. All that is grains of sand that have been cemented together to form a hard rock. And this sandstone is in what we call beds or layers. And what has happened is that these layers have been tilted up by earth movements, so that today, when we look at Ayers Rock, these layers are almost standing vertically out of the ground. And so that's why I've drawn these lines in the diagram, to indicate those layers of sandstone that make up Ayers Rock. Now, because those layers are standing almost vertically, we can actually measure how thick those layers are. And when we do that, we discover that we have layers of sandstone that are 2,500 metres thick. That's 2.5 kilometres thick. That's over 1.5 miles thickness of sand that has turned into rock. You'll agree that that's a lot of sand. But when we also take into account the sandstone, the layers under the sand, the desert sands around Ayers Rock, we discover that the total thickness is of the order of 6,000 metres or 6 kilometres. For those of you who can only remember the old scales of measurements, that's almost 20,000 feet. Again, that's a lot of sand. Now, just to show you how this looks, here on this photograph, you can see those lines on the surface of Ayers Rock. Those lines represent those layers, breaks between those layers that I had drawn on the last diagram. And again, you can see how those markings on Ayers Rock show, on the surface of Ayers Rock, show the outlines of those almost vertically standing layers of sandstone. Here's another view. You can see a little closer how erosion has tended to erode out those breaks between those sandstone layers. Well, how did Ayers Rock get there? How did the sand that formed the sandstone that has been carved out to make the shape that we call Ayers Rock, how did it get there? Well, geologists believe that 550 to 600 million years ago, there was like a large inland sea in central Australia. And rivers carried grains of sand a distance of 100 kilometres or 63 miles into this inland sea. And gradually the sand grains began to fill up this depression, this low-lying area in central Australia. And they believe that this took many millions of years. The reason they believe that is because they believe the rivers that carried the sand were very similar to rivers that we have here today. Similar to the Diamantina and Cooper's Creeks. They're rivers out in central Australia today in the western part of Queensland, where there are very shallow riverbeds, where there's only occasional flow of water because the surrounding countryside is very dry. And that's the sort of river that they believe carried this sand. Now, when you think of it, 20,000 feet or 6,000 metres worth of sand, rivers flowing at that speed would have taken millions and millions of years to carry the sand. Why do they say 100 kilometres or 63 miles, the distance that the rivers carried this sand? Well, what they have done is they've studied the sand grains that are now in the sandstone, and they identified the mineral grains. And what they have done is they have looked around the surrounding area to see which are the closest rocks, the rocks closest to Ayers Rock, that have the same mineral grains in them. And the closest rocks with the same type of minerals in them is a distance of 100 kilometres or 63 miles away. So what we call the host rocks or the source rocks for the sand is that distance away, at least that distance away. And they believe it's to the south in the Musgrave Ranges area of South Australia. So this process went on for, they believe, anywhere up to 200 million years, until gradually this inland sea, this depression, was filled with this 6,000 metres of sand. And then it was buried deep in the Earth's surface because other rock layers, other sediments, sand and mud were placed on this sand. It hardened to rock, and then they believe earth movements, roughly 350 million years ago, pushed up this layer of sand, these layers of sand that had hardened to rock, pushed them up, tilted them, and then erosion began to wear the Earth's surface down again. And they believe that 100 million years ago, Ayers Rock was essentially the same shape that we know today. In other words, they believe Ayers Rock has been sitting out there in Central Australia for the last 100 million years. Now, that's an interesting story. But what does the evidence tell us? Well, first of all, the evidence tells us, and this is not from my own studies, it's from the studies of geographers like Professor Twydale at Adelaide University. He's a world-renowned student on desert landforms, and he's studied Ayers Rock very extensively. And he's convinced that Ayers Rock was not carved out by desert wind erosion. Now, we all understand what we mean by desert wind erosion. The desert winds picking up sand grains and beating against the surface of the rock, a bit like sandblasting. Has that carved the shape of Ayers Rock? No, says Professor Twydale. That has only produced features like the one that we can see now, the illustration there of one of the features that has been carved out by the desert winds beating against the surface of the rock. That one is called the brain. That's, of course, if you look at it at the right angle. Other people have given it different names. And this one here, it's not hard to know what that is called. Of course, that's in the shape of a bell. And obviously the sand grains have found a weakness in the rock. The wind has brought the beating has found against the rock, has found a weakness there, and gradually carved out that shape. And then we find that because of the temperature extremes between the day and night in Central Australia, that the outer surface of Ayers Rock, of course, expands with the heat of the day and then contracts in the cool of the night. So the outer layer becomes weakened and eventually slabs off, breaks away. And so we see features like this one here, where you can see some sky between the surface of Ayers Rock and this slab that's breaking away. The Aborigines call that the kangaroo's tail or the digging stick. But Professor Twydale and his colleagues are adamant that these processes did not carve out the shape of Ayers Rock. In fact, they believe that Ayers Rock was carved out by water erosion. And that's an interesting discovery, as we'll come back to a little later on. But I want to look more closely at this sand that makes up Ayers Rock. Geologists can study rocks under a microscope. And on the screen there you can see now what the sandstone which makes up Ayers Rock actually looks like. How do we achieve this? Well, it's rather simple, really. We take a rock sample, we cut it with a diamond saw until we have a thin slice, We then glue that thin slice of rock to a glass microscope slide, and then it is ground until it's paper thin, 30,000th of a millimetre thick. And so the light can be passed through it, and we can study it under the microscope. And there are three simple observations that we can make from looking at such a rock sample as the one you see before you. Now, I could have chosen any rock sample from Ayers Rock. They all show the same three features. And these three features tell us that the story of millions of years of slow processes is false. The evidence does not indicate that at all. What does the evidence indicate? Well, firstly, we notice that in the top right-hand corner of the illustration, you can see a very large grain. Actually, that is two crystals of a mineral we call feldspar. And they're joined together so that they're virtually mirror images of one another. Now, that's only for those who are interested in those details, but what is so special about these particular crystals of this particular mineral? Well, this mineral called feldspar occurs at Ayers Rock. It consists of up to 50% of the sand. Up to 50% of the sand is this particular mineral. And this mineral, we define, is quite fresh. The crystals are quite shiny. We can actually see these crystals with the naked eye. You pick up a sample of Ayers Rock sandstone, and you can see these quite large crystals. And you let the light shine off the surface, and they're quite shiny. And we say that they are fresh. There are not very little alteration due to weathering. What's the significance of that? Well, this particular mineral is very susceptible to weathering, particularly in a hot, humid climate. Under those tropical and subtropical conditions, this mineral decomposes very rapidly to clay. And we all know what clay is like. It can be quite soft, and it's quite easy for water, for rain and running water to erode it. Now, if Ayers Rock has been out there in Central Australia for 100 million years, because that's what the story that most geologists tell us. They tell us that it's been out there in Central Australia for over 100 million years at the Earth's surface. And we already know from the geographers that conditions in Central Australia in the recent past, even in the recent past, have been hot and humid. So under those conditions, all the feldspar, all that mineral, all those mineral grains in the sandstone at Ayers Rock should long have since turned into clay. And if up to 50% of Ayers Rock had turned into clay, what would happen when the next rainstorm came along? It would all just get washed away, and Ayers Rock would crumble into just scattered grains of sand. That immediately tells us that Ayers Rock could never have been sitting out there in Central Australia for 100 million years. It could only have been sitting out there for a very short time. The second observation is this. Notice that that large grain is not matched by grains of the same size throughout the rest of the rock. You'll notice that there, amongst those white-coloured grains, there are medium-sized grains and even smaller grains. Actually, the white grains are the mineral quartz or natural glass. They are the grains that we normally find in sand. So we see that the grain sizes are all different. What's so special about that? Well, geologists call a rock that has all those grains, the grains of different sizes, we say that the rock is poorly sorted. What do we mean? Well, remember this was a sand which was washed by moving water, carried by moving water to this part of Australia. Now, what do we know about moving water? Moving water is an excellent sorter of material. I don't know whether you ever tried an experiment when you were at school where you took a glass jar, you put in some water, put in some sand and some clay, and you put a lid on the jar and then you shook it up and down, and then you watched as all the grains settled out. Under the influence of gravity and the water, the grains tend to settle out so that you have layers with all the same sized grains. That's what happens in moving water. Down a bed of a river, what happens? When the river is only travelling slowly, it can only carry fine, small grains. If there's a raging torrent, it has enough power to pick up the larger pebbles and boulders. So what happens is with time, the different sized grains are separated one from the other. Now, remember the story that I told you? Many geologists believe that this process of carrying these sand grains 100 kilometres took many, many millions of years. Under those conditions, there was ample time and ample distance for the grains to be sorted into their various sizes. The fact that we find all the grain sizes mixed up indicates that the process of transport was extremely rapid. There was insufficient time to separate the grains into their different sizes. The third observation that we notice is that, for instance, that large crystal of feldspar, you can see it has quite straight edges. Those are what we call crystal faces. And some of the white grains, the quartz grains, you'll notice have quite sharp edges. They've got quite sharp angles or corners. What's the significance of that? Well, in the bed of a river, what happens to sand grains? They bump into one another. They rub against one another. The sharp edges get knocked off. And it isn't very long before all the grains are smooth and rounded. Remember, they talk of millions of years of slow processes. Under those conditions, all the grains in this sandstone at Ayers Rock should have long since been rounded. The fact that we find them not rounded but jagged also indicates that the time of transport was extremely rapid. How rapid? That's the next question we need to ask ourselves. Well, I believe the evidence indicates that it was not a matter of thousands of years, not even years, probably only a matter of a few hours. How do I know that? Well, we've studied, even in recent years, similar sorts of processes. Back in 1929, there was an earthquake in the North Atlantic Ocean. And at that time, telecommunications were via undersea cables. And following the earthquake, there were some 11 transatlantic cables going from New York across to England. Over a period of several hours, these telecommunications cables were successively, one after the other, broken. And what happened is that there was sand and mud had accumulated off the coast of New York, off the mouth of the Hudson River. And when the earthquake shook the Earth's surface, that sand and mud, mixed with water, began to slump down into the deep parts of the ocean. And as it went further and further out into the ocean, it gathered speed and went as fast as 70 miles per hour. And in a matter of hours, it spread all out over the deep ocean floor on the North Atlantic Ocean. Now, the reason why they know it was that speed was because they could time from the breaks when the cables, each of those 11 cables broke, was the time at which this, what they called a turbidity current, reached that point, reached that cable. And that's how they arrived at the figure of 70 miles per hour. So, putting all that information together, we need to ask ourselves, what amount of water is capable of carrying 6,000 metres worth of sand, or 20,000 feet of sand, a distance of 100 kilometres in a matter of hours. Because that's what we're talking about to form the sand which makes up, to carry that sand which now makes up Ayers Rock. You're talking about a lot of water, aren't you? Moving very, very rapidly. You're talking about at least 6,000 metres of water. And of course, if there was that much water in Central Australia, that means the rest of Australia must have been underwater, or what was Australia. And indeed, we have exactly the conditions that are described in the book of Genesis, when all the high hills under the whole of the heaven were covered with water. Now that means that after Noah's flood, after or at the close of Noah's flood, remember what I'm saying here is that the evidence indicates that all that sand was carried rapidly and put in a great big heap there in Central Australia in layers that we can see today. At the end of Noah's flood, something had to happen to tilt those layers up so that they're now at the earth's surface the way that we see them. And the explanation is right there in the scriptures. Did you know that? In Psalm 104, we have a description of what happened at the close of Noah's flood. It adds to what we read in Genesis chapter 8. And there we read that the valleys sank, the mountains rose, so that the water returned off the face of the earth to the boundaries that God set for it. In other words, the scriptures indicate that at the close of the flood there were great earth movements that uplifted. Some of the rocks that had formed during Noah's flood were uplifted to form the new continents. And the waters drained off the surface of these emerging land masses and went off down into the ocean, what we now have as the ocean basins. Now, of course, that means that there were earth movements that could tilt these layers of sand in Central Australia. And as the waters drained off, they would be able to carve out the shape that we now know as Ayers Rock. And that's consistent with the evidence. Remember, Professor Twydale says that the evidence indicates that Ayers Rock was carved out by massive water erosion. And of course, as the sand bed dried out, then of course it hardened to the rock that we now see there in Central Australia today. So the next time you think about Ayers Rock, and if you get the opportunity to visit Ayers Rock, as you stand there, remember that Ayers Rock is not testimony to millions and millions of years of slow geological processes. No, the evidence in the sand grains that make up Ayers Rock indicate that it was catastrophic processes, conditions exactly the same as what the Bible describes for Noah's flood. And so Ayers Rock stands as a silent testimony to God's judgment in the days of Noah.